All right, practice exam solutions. We're going to start with each problem and make sure we get some consistent solutions. First, of course, you know you're going to have a resistor combination problem, so I want to make sure that you're kind of prepared on that front. And the other thing I want to say is do not start trying to solve the whole problem at once. You know, we're not sure what's going to lead where. Just begin with what you know, one step at a time. And what I mean by that is the following. This is what you want to look for in a circuit, okay? When you see two resistors like this, you know they're parallel, okay? If you see two resistors like this, you know they're in series. One other thing I wanted to say, by the way, this came up. If you see a resistor like this and then a bend, okay, and I'm just going to, for example, hook this up to a battery here. I just want to say there's a bend here, but I did want to make a small point that this is also a series combination. I think it was Riley that was asking about that. So shout out to Riley for bringing it with the resistor questions. All right, so here we go. Let's go ahead and combine what we know how to do. I see two resistors in series right here. 8 plus 2, 10 ohms. I just want to remind you, of course, that when resistors are in parallel, if there's just two of them, we can combine them by taking the product over their sum, okay? And then when they're in series, we just add them up. Now, what I'm going to do here is actually redraw the circuit. So I've got our 40-volt battery. We've got here 10 ohms as we've combined them, and then a little 5 ohm at the bottom, so 5 ohms, 10 ohms, 10 ohms, and 5 ohms. And now what we see is here we've got a parallel combination. So nice. So we get this little parallel combination. We're going to combine them. So to do that, again, the R for the parallel combination is going to be 10 times 10 over 10 plus 10. That's going to give us 100 over 20, which is 5 ohms. There we go. Finally, let's redraw our circuit just one last time. I was really impressed, by the way, at how people were able to combine these. Just great physics, guys. So 5 ohms and another 5 ohms here. And then we get a 40-volt battery here. All right, we combine these two little dudes, and we end up getting the equivalent of a 40-volt battery hooked up to an 8 ohm, to a 10 ohm resistor. Pretty awesome. So again, 10 ohms is what we get. Now the total current put out by the battery, we're going to use for B, V total equals I total times R total, which is going to be 40 volts put out by the battery, equals I total times our equivalent resistant, which is 10 ohms. And so we're going to get I equal to 4 amps of current. Pretty exciting. Now, how long will it take the battery to deliver 10 joules of work to the circuit? A couple things. Let's just remember, power is work over time. Should have articulated that better. We also have a formula for power that is specific to electric circuits. Power is I squared times R. So we've got the 4 squared from above times the equivalent resistance, which is 10, and I'm getting 160 watts. All right, so we know that power is work over time, so 160 equals the work done over the time. That's 160 is 10 divided by our time, and that's going to give us the time is 10 over 160. And when we actually solve that out, just go ahead and do that now. We're going to get this delicious time of 0.063 seconds. Just less than the blink of an eye. That's just amazing. Now, for part D, Oh boy, we want to know the current in this resistor. Ew. Okay, so let's go ahead and solve that. There's a little trick to this, and I want to run through it just a little bit slowly. Okay? So, to this end, I'm just going to go ahead and I'm going to take this little thing here. I'm going to copy it. I like that noise. And part D, long form. So, part D. I think I want to solve it here. Okay? So I'm just going to do that. I'm just going to take this little screenshot. Look at all this physics we've been doing. Just all over the place. Right there. All right. Nope. There we go. Yeah, so I just want this little bit here to work on it. Oh, that's so nice that we have all that text there that I didn't want, so let me get rid of that. Sweet. So here we go. We have this nice little circuit here. Now, I'm going to write down some of the facts that we had before. We know that R total is 10 ohms. We know that I total is 4 amps, and there's a couple things we want to do here. So in order to solve this problem, we can't just, the most common thing I saw people say, they wanted to know the voltage across the 10 ohm resistor. People would make up all kinds of stuff, 10 times 4, I don't know, let's use the Ask Mr. Abdullah theorem, like all kinds of different physics at play here. And I just want to kind of open up the problem in this way. To solve this problem, what we want to do is actually look at the voltage across the circuit. And let's be clear. Okay? We're going to consume 40 volts around the circuit. So we're going to start with 40 volts here. We're going to go around. And then some of the 40 volts gets consumed here. And then the rest of it gets consumed here. Now I want to be clear. We have the rule that V across branches is the same, and what that plays out to in real life is whatever I consume across this branch I consume here. It's just when I take any particular loop, a total of 40 volts gets consumed. Okay, so here's what we're going to say. Across this whole branch, some voltage is consumed. And across this resistor down here, some voltage is consumed. Let's first calculate the voltage across the 5 ohm resistor. Now, everybody thought it was 40 volts across the 5 ohm resistor, and that's just not the case. The 40 volts is the battery, but some of that voltage gets consumed here, and the rest of it gets consumed here if we go around the loop. So what that means is, in fact, across the 5 volt resistor, 5 ohm resistor, I have 4 amps of current, which is the I total, and here is why. I have 4 amps of current right here going out of the battery. Now what happens is it reaches up here. Some of it gets split here. The rest of it here. It goes through these two. And then what happens is that it ends up joining back together to become 4 amps here again. So that's how we know there's 4 amps going through the 5 ohm resistor. The resistor's 5, and so V5 is a total of 20 volts. So what does that mean? That means the result here, of course, yes, it's 20 volts. Here's what it means for the circuit. It means that I have 40 volts getting put out by the battery, 20 volts consumed by the 5 ohm resistor. So if I take any one loop, I've got 20 volts consumed here. In fact, let me write that down. I've got 40 volts from the battery and 20 volts consumed by the 5 ohm resistor. So the remaining 20 is consumed by the 10 ohm resistor. A question I get is, well, what about the ones up here? Yes, they also consume 20 volts. And the price we pay is that when we have things connected in parallel, your battery wears out faster because the battery is basically delivering 20 volts here and 20 volts here. That is not a total of 60 volts from here, here, and here. It's that if I take this path, my 20 volts gets used up here and then here. If I take the other path on top, I consume 20 volts at the top, 20 volts at the bottom, and it's used up. So part 2, I have 20 volts across the 10 ohm resistor equals R of the 10 times I of the 10. That's 20 equals 10 times I. So I across the 10 ohm resistor ends up being 2 amps. So that is just a beautiful look at problem number 1.